Hello, my name is Frank Sikora. I'm Director of Laboratories and Tools Program at the Division of Regulatory Services at the University of Kentucky. Today I'll be talking about our laboratory testing of hemp, the work we're doing for Kentucky Department of Agriculture in testing hemp to determine if the THC concentration is in violation. We got into this work 3 years ago, started in 2017, and this graph shows the increase in samples that have been tested over the past couple of years, along with the planted acres and harvested acres. Hemp has really grown exponentially the last few years, especially from 2018 to 2019, as you see. When we first did our testing for the first year in 2017, we tested approximately 300 samples the whole year. 2018, approximately 600 samples, and last year that jumped to 3,200 samples. It was a bit of a struggle to do all those samples in a short period of time. Most of those came at harvest season in the fall, but we did a good job of making sure that the analysis were done in a timely fashion. The 2018 Farm Bill redefined what hemp is and cleared up some confusion on what should be tested. The 2014 Farm Bill that came out said that hemp is anything with less than 0.3% delta-9 THC. The confusing thing about that definition is that there are two forms of THC in a cannabis plant. There is the neutral form, delta-9 THC, and there's an acid form, delta-9 THCA. It wasn't really clear from the 2000 Farm Bill whether just the delta-9 THC should be considered or both the delta-9 THC and delta-9 THCA should be considered. The new Farm Bill in 2018 cleared up this confusion by saying all forms of delta-9 THC should be considered and analyzed to be 0.3% or less on a dry weight basis. These are the molecular forms of THCA and THC. THCA is on the left, THC is on the right. And you see for THCA, the acid group is the carboxyl group encircled in yellow. And with THC, that carboxyl group does not exist in the molecule. Well, the form of THC that gets people high is the neutral form, the one on the right. And when cannabis is heated by smoking or baking it, the THCA loses the acid group to form the THC on the right. So in order to adequately assess whether a plant is marijuana or hemp, it's only right to determine both molecular forms and evaluate how much potential THC could be in the plant if it is smoked or baked to get someone high. So what we do in the lab is we measure THC with an instrument called a gas chromatograph, GC analysis. And with that instrument, you introduce the extract into the instrument and it heats it at a high temperature. So any THCA that is in the extract gets converted to THC. So we measure one peak, which is total THC with GC analysis. Another type of instrument that other labs use is called liquid chromatography. And this does not result in a high temperature to convert THC to THC. I'm sorry, it does not have a high temperature to convert the THCA to THC. So this instrument determines the concentration of both molecular forms. And Both molecular forms are added after correcting for the extra carboxyl group in the THC with a factor of 0.877. Both forms are added to get to a total delta 9 THC concentration. So it's really important to understand that there was confusion in the past on what form of THC to analyze. A lot of states were just analyzing the neutral form, but in the future, Kentucky has always analyzed and determined both forms, and in the future, states are going to have to determine total delta 9 THC, determine if a cannabis plant is hemp or marijuana. So we have this definition of hemp being a plant that has less than 0.3% total THC. And in a perfect world, if a plant tested 0.299% THC, it would be considered hemp. And if it tested 0.301% THC, it would be considered marijuana. Anything less than 0.3% is hemp. Anything greater than 0.3% is marijuana. But we do not live in a perfect world because of uncertainty. There's uncertainty in a lot of aspects of testing hemp plants. There's uncertainty in sampling the plant material in the field, uncertainty when the sample arrives in the lab. There's a lot of different things that one lab might do different from another that causes variability in what a result is for analysis. And we collect data from what's called a proficiency testing program that defines how much variability there is in results coming from different laboratories. We send out the same sample to 60 labs across the country, and they provide us a result on that sample for total THC. And the data shown here are all the results for 4 samples sent to all these different labs. And you see that all the labs do not report the same value for the same sample. If we focus on the last sample in the graph, the last sample on the right, which is labeled 1811-2, you see that all the analyses that the lab reported are shown in diamond data points. The average concentration of all the data is shown as the black line. For this sample, it tested a little bit above 0.3%. It was 0.32% total THC. The green diamonds are data points that are in a normal distribution of the data, normal accepted distribution. The red diamonds are outliers. Labs reported values that are either too high or too low outside the normal distribution of data. So if you look at the green diamond points, you could see the variability that we saw was approximately plus or minus 0.1% total THC. Well, if we put that on the graph I showed earlier on the limit of 0.3% total THC being whether something is marijuana or hemp, we have to adjust that graph for measurement uncertainty. In between 0.2 and 0.4%, if a sample was sent to a lab from one state and sent to a lab in another state for regulatory purposes, all these different labs may report slightly different numbers. And what we currently see from all these labs is the variability being approximately plus or minus 0.1% THC. So with that uncertainty, we can only be really certain that something is marijuana if it is greater than 0.4% total THC. We can only be really certain if something is hemp if the concentration is less than 0.2% THC. In between 0.2 and 0.4%, we have this uncertainty. We cannot really say whether the plant is hemp or marijuana. This is a global measurement uncertainty evaluated from results from all different labs. What USDA has come out with in their rules that they are putting forth for states to follow is that each lab should determine their own individual lab measurement uncertainty. We may have to do that in the future in Kentucky, but this year we're going to stick with the rules we had the previous year, where we're going to use the global measurement uncertainty that you see here, that KDA will only take action and consider a sample not to be hemp if it tests greater than 0.4%. There is some disadvantages we see for individual labs determining their own measurement uncertainty, because it adds confusion and in terms of a lab providing a result that maybe the measurement uncertainty from one lab may be different, and it will be different from measurement uncertainty in another lab. And the same analysis result may result in a sample being a violation in one lab, and it may be a good result in another lab. So we think that the approach that should be taken by USDA is the consideration of global measurement uncertainty obtained from a proficiency testing program like we manage. This is a pie chart showing the percent THC in hemp in 2018, and it shows a distribution of THC concentrations that we tested in samples in 2018. About 6% of the samples tested greater than 0.4% THC and less than 1%. That is the small piece of the pie on top of the pie chart. And 14% tested between 0.3 and 0.4%. So 20% of the plants tested greater than 0.3%. In 2019, the number of plants that tested with high THC increased. And we actually saw some plants testing greater than 1% THC. About 14% tested between 0.4 and 1%, and 27% tested between 0.3 and 0.4%. So 42% of the plants tested greater than 0.3% THC. The increase in the number of plants testing higher in THC in 2019 compared to 2018 can be due to a number of different factors. One may be that in 2019, farmers were using seed that was not adequate. That was varieties that produced greater THC compared to the previous year. Another factor may be the weather. There's some discussion that the droughty conditions we saw in the early fall may have caused some stress in the plants that caused an increase in the THC concentration. When we analyze plants, one other thing I'd like to point out is that we present our results in terms of total THC concentration on a dry weight basis. We do this because that is the definition in the 2018 Farm Bill, that the THC concentration has to be 0.3% or less on a dry weight basis. Kentucky Department of Agriculture, they do the sampling. They have inspectors that go out into on the farms, they collect samples, representative samples in the top 8 inches of the plant. They take that material and they dry it in an oven at 38 to 52 degrees C for 48 hours. After this drying, they submit the sample to us, and we grind the sample to very fine particle size for analysis. And that material in the very fine particle size contains some moisture. It contains about 8 to 12% water. So what we do, we analyze that sample, we analyze that material with 8 to 12% water, but we do a moisture determination on how much water is in that sample, and we correct for the water content. So the concentrations we report are based on that plant material containing no water. So it's on a dry weight basis. At the end of my presentation here, I'd like to discuss some things that may occur in the future. Where are we going with hemp analysis? And what is the prospects of this 0.3% limit to define hemp being changed? There's a great demand and need for a field test for hemp that farmers could use in their fields to look at their plants and determine what the THC concentration is close to harvest. And law enforcement has a great need to have some type of field test that they could quickly identify material as being hemp or marijuana in vehicles that they pull over and check. There's recent work that came out of Texas using Raman Spectroscopy, where it takes a scan of cannabis plant and it could differentiate a sample between hemp and marijuana. And it does it by really a technology that seems like science fiction, like a Star Trek tricorder, but it scans a plant material with light, and there's different molecules in the plant that absorbs different wavelengths of the light, and these differences between a hemp plant and marijuana plant can provide different signatures of light scattering that they could detect whether a plant material is hemp or marijuana. So it's really interesting and exciting to see techniques like this come on board. I think eventually there will be a spot check technique that can be used in the field to quickly identify between hemp and marijuana. And laboratories on the regulatory side can also use these spot checks as a screening test too, if they're accurate, to determine if something is hemp or marijuana. This is going to be particularly useful for regulatory laboratories if these labs have to test hundreds and hundreds and hundreds of samples in such a short period of time. Something else I'd like to talk about in the future is this 0.3% THC limit that is looked at in defining whether something is hemp or marijuana. I'm often asked the question, where did this 0.3% THC limit come from? And I've often wondered that too. And I found out it's from data collected in 1973. This is the data used to determine and define the limit being 0.3% THC. Cannabis plants can be either marijuana or hemp, and these plants produce both THC and CBD. These two cannabinoid molecules come from the same parent molecule. This parent molecule is formed, and based on the DNA of the plant, that parent molecule will form predominantly THC, or it will form predominantly CBD. It all depends on the DNA of that plant. Marijuana has the DNA that results in THC mostly being formed. Hemp has the DNA that results in mostly CBD being formed. The data shown here is a plot of THC concentration on the y-axis versus CBD concentration on the x-axis. So if a marijuana plant has THC mostly formed, it still forms a little bit of CBD. And there is a relationship between THC concentration and CBD. If you see the data points on the very left-hand side, which is identified as phenotype 1, these plants have high THC concentration, and the CBD concentration is low, but there is a slight increase in CBD as THC concentration increases. The data points identified by phenotype 3 on the bottom of the graph have high CBD concentration and low THC, but there's still a relationship showing that as CBD concentration increases, there is a slight increase in THC concentration. Phenotype 3 are hemp plants. They have the DNA structure that produces mostly CBD from this parent molecule. Phenotype 1 is marijuana. They have the DNA that produces mostly THC from the parent molecule. Phenotype 2 are hybrid plants. They're hybrids between marijuana and CBD, resulting in about equal quantities of THC and CBD being formed. The scientists that developed this data evaluated where a limit should be placed to define whether something is marijuana or hemp. And what he decided on and advised was that 0.3% THC seemed like a reasonable concentration to discern whether something is hemp or marijuana. It was considerably above all the data points shown for hemp in terms of THC concentration. And there was no data point for hemp in phenotype 3 that rose above this 0.3%. So he thought this was a good limit to use, that anything above 0.3% would be clearly identified as marijuana. And all the hemp plants are clearly below this 0.3% THC concentration. But take note of the concentration of CBD in this data plot. The highest concentration plotted on the x-axis, the CBD concentration, is 4%. If we look at data today, we see that the CBD concentration in the varieties that are grown today are much greater than 4%. This data was collected from our testing last year, and again, it's showing total percent THC on the y-axis versus percent CBD on the x-axis. And there is this relationship, a very good relationship between THC and CBD. And as CBD concentration increases, the THC concentration remains low, but there's still an increase in THC. So with the improvements that have been made in plant breeding to increase CBD concentrations for the market of selling CBD, there are plants now on the market they're hemp based on their DNA, but they're not hemp based on the limit of 0.3% THC that is in our law. You see the hemp plants in some of the data points with high CBD concentrations exceeding that horizontal blue line of 0.3% total THC. Now, if we use the same logic that the scientists used back in 1973 for a limit to make sure that none of the hemp plants had data points of percent THC being above a limit, we should realistically look at a limit of probably 0.6% THC as being a potential limit to discern between hemp and marijuana. using the same logic as we used in 1973. We use the same logic in today's world with the type of varieties that are now being grown for hemp and CBD production. So this is something that I think different groups are discussing and trying to increase the limit of THC. I'm not sure where it'll go, but from a scientific point of view, it seems to make sense to move that limit higher than 0.3% based on the varieties that are now being grown, the hemp varieties now being grown for CBD. So in summary, I talked about determining THC as the sum of THCA and THC. The 2018 Farm Bill made it clear that total THC should be considered in analysis to determine what the concentration of total potential THC that is psychoactive and gets an individual high. Because of global measurement uncertainty, the limit we are currently using is 0.4% to determine whether a sample is in violation of being marijuana. In the future, that may have to change. We may have to look at our specific lab uncertainty. But for this year, it's going to remain at 0.4%. Concentration we determine is on a dry weight basis that abides by the definition of the 2018 Farm Bill. And I talked about some future happenings that may occur with handheld measurements for THC analysis and a potential increase in enforcement levels if the same logic is used today as was used with the data back in 1973.